This next piecewise function is a function that is an upside down parabola for one part, so for x is less than 1, and for the other part, it becomes a linear function. And basically, we're going to transition from a parabola to a straight line, so we're going to probably end up with a kink. So we need to make sure we observe the domain when we graph this. Okay, so I'm going to, actually I'll shade this in green. So this is the domain x is less than 1. Okay, so on the left side of this graph, I'm going to graph it in green, it's going to be an upside down parabola and with a vertex at 0 and positive 3. So there's my vertex. And everything to the left of this boundary point, okay, so this boundary line here, everything to the left of it's going to be an upside down parabola. Okay, on the right of it, I'll graph it in a different color here. Okay, on the right of it, it's going to be a linear function. It's going to have a y-intercept of positive 1. It's going to go kind of with a slope of 1. Now, what I want to know is, before I graph this is, when the coordinate is equal to 1, x equals 1, does it join together or does it break apart? And that's really important in calculus because that determines whether something is continuous or discontinuous. And that's an important property in calculus. So what I'm going to do then is just going to test the point. So we can test the boundary point. And I'm going to test it from the left-hand side on the green equation. So when x is equal to 1, when I plug it in, I get y is equal to 2. Then I'm going to test it, check the same coordinate, x equals 1, on the red graph, x plus 1. When I plug 1 into that equation, I get y is 2. What ends up happening then is, and these two coordinates match, so that means that from the right-hand side and the left-hand side, they are going to end up in the same position, which means then that is continuous. So I'm going to draw my coordinate there. And what that means is the parabola is going to join that black dot, and the linear function is also going to join that black dot, making it a continuous function. So I'm going to draw this in. I'm going to have my parabola. It's just going to be an upside down parabola like this. It's going to join at that point there. And then it's a linear function. It's going to start at 1, and it's going to be a straight line that goes like that. And there's my linear function on the right-hand side of x equals 1. And then I get a piecewise function drawn with two pieces, a parabola piece and a linear piece, and it looks like this. And the boundary point at x equals 1, it's joined together, and there's a kink at that point. Now, the reason why that's important is because there will be functions where they do not join. So we end up having separated, and we end up with a gap in the function. This means that if there's a gap, it's what we call discontinuous. And this issue of continuity versus discontinuity is an important property when we're looking at calculus problems.